for June. My name is Kenny Neal. I'm the co-leader, and I'm helping out Rob this month. This month, we're delighted to have Tim Mitchell here to talk to us about incremental load design patterns. Coming up next month, we've got Brian Caffrey talk about R introduction and predictive model creation. Our virtual chapter is brought to you once again by Nutanix. We're really appreciative of them and their support, and we just signed on to have them as a sponsor again next year. Really, really glad to hear that. And for those of you that are looking to go to the PASS Summit this year, starting on October 31st, you can go register at passsummit.com. And if you look down there at the bottom, we've got a discount code to save you $150 off your registration. And now that I've knocked this out of the way really quick, because I know he's got a lot of stuff to get through, I'm going to hand it off to Tim. Thank him again for presenting.
Well, thanks, Kenny. I appreciate it. Let me get, if you'll let me share my screen there, we'll go ahead and get started. All right. So if that's working properly, you should be able to see my PowerPoint presentation.
I can see it.
All right, perfect. So here we go. Welcome, everybody. Certainly appreciate you spending part of your afternoon or morning or evening, depending on what time of the day it is for you, learning a little bit about integration services design patterns. My name is Tim Mitchell. We're going to go through for about the next hour or so, talk a little bit about what incremental design patterns are, why they're important, and how you can implement those in integration services and SQL Server. So our agenda, we'll talk through an overview, quickly talk about what incremental loads are. We'll talk about, and really the meat and potatoes of what we'll talk about will be change detection, because that's really the heart of doing any sort of incremental load. We'll talk about how it works both on the SQL Server engine side as well as on the integration services side. And then I've got several demos that we'll walk through as well. Just a little bit about me. Again, my name is Tim Mitchell. I'm a data architect and consultant. I'm based in the Dallas area. You can follow my blog at timmitchell.net. For those of you who are on Twitter, I'm at tim_Mitchell. And professionally, what I do, I run a company called Tylerus Data Solutions. We specialize in data architecture, data warehouses, data integration, reporting, and things that touch those pieces. You can reach out to us at tylerus.com if you're interested. So high level, we'll talk about what an incremental load is, talk about a brief overview. And you're about to see, just as a preface, you're about to see why I'm a data guy and not a PowerPoint guy, because this is the pinnacle of my PowerPoint experience or my PowerPoint skills. I saw Kenny's presentation a little bit earlier, and I saw the demos flying, or rather the transitions flying all over. Hopefully that didn't set the expectation, because I don't have anything like that. But to give you an idea of what an incremental load is not, we'll talk about what a full load is, and those are really opposites of one another. Full load is taking the entire set of data from whatever source system you're pulling from, loading that into the destination. Destination might be a data warehouse like is shown on this demo. It could be an OLTP system. It could be any number of systems, even maybe not a database, maybe a flat file, maybe an access file or an XML file. But the bottom line is that you're taking some mass of data. And in a full load scenario, you're taking all the data, your entire history of the data, and dropping it in there. Again, the animation is about the extent of my PowerPoint skill, but it does show you that everything that you have in your source database goes into the destination, whatever that destination is. There's nothing necessarily wrong with that. Very often that's the right way to do it, but there are a couple of downsides. It's time consuming. In a lot of cases, it doesn't preserve your history. It only gives you a snapshot as of right now, and it can result in a lot more storage needs than you might otherwise require. The way a differential or incremental load differs from a full load is that we only look at, on the source side, we only care about loading the data that's new, that's been changed since the last time we did the ETL load, perhaps what's been deleted from the source side, and only that piece do we move into whatever our destination is. Typically those loads run noticeably faster because we're touching less data. If we're touching less data, that means, assuming no other bottlenecks, it'll scale faster, it'll work faster. So all of the things being equal, we do want to touch less data rather than more data, and an incremental load design pattern does support that. So the reasons that you want to do incremental loads, typically if you're loading from source system to data from source to destination, typically you've only got a small subset of the data that's either new or changed for any given cycle. Most of us work in a daily environment where we're loading data from A to B on a daily basis. Sometimes it's less or more frequently than that. But even in a broader frequency, typically a small percentage of your data will have changed from one load to the next. So we don't necessarily need to load everything. Performance is also a consideration. And then very often your source data is no longer available. If you want to store, for example, history, what something looked like at a particular point in time, you need to do those incremental loads because that will let you get not just what it looked like as of right now, but my history over time of what those records look like over time. Also, with respect to performance, assuming no bottlenecks, your performance will scale in a linear fashion. For the most part, twice as much data requires twice as much processing time. So it stands to reason that if you're touching less data, in almost every case, it's going to cost you less time to do that. So if you can touch less data through an incremental load, it's going to speed up your load in almost every case. And at the heart of any conversation about incremental loads is change detection. So the bulk of, if you're doing any sort of an incremental load, there are provisions on the destination side that you'll need to make and decide how you're storing that, but almost all of your work will go into change detection. And I'll not read what's on the screen, but this is a brief definition of what change detection is. Figure out what's new, what's changed, and what's deleted so we can pull that information in, and that's what we target rather than doing the full load. Several different ways that we can do that, but the why before the how is that, again, we talked about performance. We also talked about preserving that historical record. One of the cases that I like to use is with respect to incremental loads. Let's say you're an insurance company and you have an insured that this person lives in Florida, but previously he lived in Minnesota. While he lived in Minnesota, he had a couple of snow-related claims, so slid off the road, whatever the case may be. This insured now moves to Florida. If you only look at what's happening as of right now, this will show you that you have someone that lives in Florida that's had a couple of snow-related claims on their insurance. That really doesn't make a lot of sense, and that's going to skew your numbers and show that states that someone lived in previously and had a different type of claim. It will imply that that record is associated with where they live right now. Using an incremental load pattern where you're preserving that history will prevent that type of thing, where those detail records or the fact records, if you're in a data warehouse scenario, will be attached to not just what the current details are for that insured, but what did it look like at the time. So the snow-related claims in a slowly changing dimension or in an incremental load scenario will appear as if they happened in Minnesota, which they truly did, rather than looking like improperly that they happened in Florida. So a couple of cases that we would want to use that for. Wow, my mouse just got away from me. Bear with me just a second. All right, a couple of different overall design patterns that we have for incremental loads. Filtering at the source. If you can, by all means, filter the data at the source because, again, touching less data means it costs you less on performance. If you can limit those records to bringing into your ETL pipeline only what's been added, what's been changed, and possibly what's been deleted, that will save you some time, but it does require some sort of reliable method to be able to detect that. It's easier than, or it's not as easy as it sounds because you have to be able to touch that source and make modifications to the source to support that typically. If you can't do filtering on the source, filtering at the destination is required. This is the more typical design pattern. It's also the one that performs lesser of the two. It's going to have worse performance than doing the filtering at the source because you are bringing in more data in most cases. You're not just filtering out what's new and changed, but you're bringing in the entire set of data, comparing it to what currently exists in your downstream system, your ODS, your data warehouse, and then processing from there. So volume of data is a consideration. The complexity of the comparison is also a consideration that you want to keep in mind when designing this. Sorry about that. I think my keyboard has lost its mind every time I click right. Let me just do the mouse from here on out. So similar to those design patterns is having a slowly changing dimension. So this may not apply to you if you're not in a data warehouse environment, But effectively, slowly changing dimensions allow you to have, like the insured that I was talking about earlier. It preserves the record for that historical point in time. Typically, it works on a data warehouse scenario, but there's nothing to prevent you from capturing in your load saying this record was effective as of X. So you can preserve that history even if you're not dealing with data warehouse records. Tools that we can use for detecting that. There's a lot of T-SQL tools. I'll show you several of those when we get to the demo. There's the T-SQL merge statement. Some people have polarizing opinions about the merge statement. I do find it useful. It does have some things that you have to keep in mind, some performance considerations and accuracy considerations. But it is an effective tool for doing some loads if you're doing an upsert type operation. If you're using integration services, there's a tool called the Slowly Changing Dimension Wizard that can be used for incremental loads. I'm going to do my best to talk you out of that one. It does work well for very small loads, but it does not scale well. It was designed for very small loads because it does a row by row and not a batch, or it doesn't do batch or bulk processing. It's intended to do row by row operations. Again, for a small set of data, it can work fine. For larger sets of data, you will see some performance impact. Some third-party components, I won't go exhaustively through those, but do know that there are some pieces that will plug into SSIS that will help you with that, and then the native components on SSIS as well. All right, change detection methods. Let's talk about first the T-SQL methods, or the SQL Server Database Engine methods. These are in no particular order, except for I put change tracking at the beginning because it is by far my favorite. Assuming, or all of the things being equal, I would rather use change tracking than any other change detection mechanism. It's simple, it's fast, it's lightweight, has almost no measurable impact compared to the rest of the ETL. And for pure change detection, it's a fantastic tool. It will track inserts and updates, deletes. It does not track the full history. It will only tell you this record was updated, this record was inserted since the last time you ran your ETL. So if you want a full audit mechanism, this isn't it. But if you just want to know which records were changed since the last time, this is a fantastic way to do that. Great news is that since it came out in 2008, this has been available in every edition of SQL Server, including the free Express version. You don't have to be on a commercial version. You especially don't have to be on Enterprise Edition. Works on every edition of SQL Server. You turn it on at the database level, and then for every table that you want to track it on, you turn it on for that individual table. I'll show you once we get into the demos. I'll show you a little bit about what that looks like and how that works. Change data capture is another tool built into integration services. So this one is relatively new as well. I believe it was also new in 2008. Unlike change tracking, change data capture will give you that full history. So if you need auditing, if you need to see for this record, it was inserted as of X, it was updated to this value, updated again to this value, and finally deleted, change data capture will give you that level of auditing. So it's like a change detection tool and then some. It is asynchronous and not synchronous, meaning there can be a little bit of a lag involved in that. So do be aware of that when setting up your ETL. And this does depend on SQL Server agent jobs. They're actually reading through the log to process that data. It has been enterprise only. I put an asterisk out there because as of SQL Server 2014 Service Pack 1, this is now no longer just an enterprise level feature. You can use it on any commercial edition of SQL Server, so standard and up, and I'm almost certain that change data capture is even on the lower, the non-paid or the express version of SQL Server as well. So if you're on 2008 all the way up to 2016 RTM, the original release, it does require Enterprise Edition. Once you go to 2016 Service Pack 1, you can use you can use Change Data Capture without having to have Enterprise Edition. So a relatively new construct in SQL Server for managing incremental loads is temporal tables. These were brand new to SQL Server 2016, and basically they are version stamped versions of tables. So it maintains its own history within the table set, and it actually looks like there's two different tables, even though they're materialized as a single table. What it will do is the upper level table, or the parent table, if you will will retain the current record, whatever that current record is for our insured that we talked about. So he currently lives in Florida. That's what you'll see if you interrogate that main person table or the insured table. But it also retains the history. You don't have to do any extra work to retain the history. It will do that behind the scenes for you and maintain that in sort of a shadow table. And it does that automatically for you. If you're in a data warehouse scenario, this is worth considering for doing for a slowly changing dimension, for example, because it will preserve that history. I haven't really started using these version tables, the temporal tables, a lot, so I can't speak a lot to their performance, but I can tell you that it's one of the more exciting features of SQL Server 2016 on the database engine, and I'm looking forward to playing with that a little more once I see some more adoption of 2016 and trying that out for, among other things, slowly changing dimensions. So another way of handling change detection is through a timestamp. This is definitely not my favorite way to handle this, and I'll tell you why in a second. Timestamp depends on, just like we see on here, having some sort of an indicator on that row saying this was updated at this time, deleted at this time, inserted at this time. It does depend on a reliable mechanism to update that row timestamp. In theory, it does work well, but I've seen a lot of cases where there is a row timestamp. This is used for change detection. If it's forward of the last time we ran the ETL, we want to include it, but that assumes that every piece that touches that table, everything that inserts, updates, or even deletes from that table will honor that row timestamp and handle that properly. So there is some risk there. Again, in a clean environment, in a sterile environment, it works just fine. But very rarely do we work in that type of environment where nothing else will touch our database. So do be aware that if you're using some sort of a date or timestamp as a filter, there is some risk there that some outside process would have updated the data without subsequently updating that row timestamp. Also, hashing is another way to do change detection. So if you're doing a row by row or column by column comparison, I encourage you to look at the hash algorithms in SQL Server. So by using the hash bytes function, which we'll take a look at in a second in the demos, you can hash that row and combine several columns together rather than comparing, so using your source data comparing to your destination data, rather than comparing first name to first name, middle name to middle name, and so on and so forth. You would create one binary hash value out of all those columns that you want to compare, and then you compare the two binary hash values. The advantage that you have there is simplicity, first of all, that you're only comparing one column. You compare the binary hash to the binary hash. Also performance. That's going to run a lot faster if you're doing a binary comparison or comparing two binary fields to each other rather than comparing varchar to varchar and int to int and so on. So there can be some performance benefit there. There is some measure of overhead in actually calculating the hash, but if you're comparing 15, 20, 50, 100 columns, that impact will probably be less than just doing the column by column comparison every time you run that. And this is sort of what it looks like in the diagram where if I've got my person ID, first name John, last name Smith, all those are concatenated together. The hash bytes function creates one binary value, and that's what becomes authoritative on comparing the source data to the destination data. So the hash is typically stored in somewhere in the destination table, so create another field, store that hash in there. It is possible to calculate it on the fly, both in the source and the destination, but if you do that, you're paying for that calculation on both sides, source and destination, every time you run the ETL. So if you can, store that hash so you don't have to keep recalculating that hash over and over again for the same row. And then finally, last and certainly least, is doing a brute force comparison. So if you're comparing source data to destination data, tell me what's new, what's changed, or if something's missing from the source, tell me what's deleted. Doing a column by column comparison does work. And I see this in the real world. I see column by column comparison a lot because it's the easiest to understand and look at because you've got simply first name to first name, last name to last name, and so on. It also has the fewest assumptions. You don't have to have any special software. If you're using T-SQL or SSIS or even PowerShell to do a data comparison, anyone can fairly simply do a column by column brute force. So the least assumptions, but it also can be the worst performing because you're bringing the entire set of data and doing a column by column, whether it's 10 or 10,000 columns. You're comparing one by one, and that can be an expensive operation if you have a large number of columns or rows. So step outside the database engine for a second. There's ways that we can do change detection in SQL Server as well. You can pull it into the database engine, or rather the SSIS engine from the database, and do your column by column comparison, your hash comparison, your hash calculation directly in the data flow. Several different tools that you can use for that. Lookup transformation is useful for that. Merge join, conditional split, maybe even the derived column transformation can all be used to do column by column or merge join or hash comparisons to see for this row of data in the source, this row of data in the destination. Does it already exist? And if it does, is it identical to what we currently have in both the source and the destination? And if it's not, we need to do some sort of an insert or an update operation. So in SSIS, all the tools that you have in there are capable enough to run change management on their own, or they can use the SQL Server tools. If you're a fan of using the merge statement, you can use SSIS to call the merge statement. If you're a fan of change detection, or rather change tracking, you can use SSIS to call change tracking as well. So it is flexible enough to let you roll your own whatever you need that to look like. And then finally, staging tables are a good way to manage change detection expectations. So doing something like, if I've got 1 million rows in a file, and it's just a flat file, it's not a relational database that I'm pulling that in from, and I need to do an update against an existing table, generally speaking, if I'm doing that, for example, in SSIS, I'm going to do a row-by-row comparison. That's going to be expensive, and I don't want to do that. So very often, in fact, I just blogged about this earlier today on my blog. Using staging tables in ETL, it's not a good fit for every ETL scenario, but if you're doing a lot of updates, if you have a large volume of data and you want to do operations like an update is really handy for that if you're doing a merge operation, or simply just an inner join, a left or right join. Loading the data to the staging, to a table on the instance that you're loading to, into a staging table, and then doing the relational operation, take it more of it, instead of an ETL, it's more of an ELT, extract, load, and then transform. That can save you a lot in terms of performance and complexity as well if you're using staging tables. All right, so that actually went in record time. Normally the slide deck part it's a little harder when you're doing an interactive presentation like this and you're not getting the feedback. So normally I get a lot of questions. I will have some questions or some time for questions at the end, but I want to plow through and make sure that we get all the demos, because I've got quite a few demos that we're going to go through. Let me run my reset script. And I'm going to walk through, I've got several examples, and my machine decides to frost at that point. I've got several examples in T-SQL. Also, I've got one example at the end that we can use on integration services as well, and show you how you can do a comparison on SSIS with that data. All right, so we've got our data set up there. So here's what I'm doing on the first one. So I'm simply looking at an update timestamp. The only thing I care about on this execution is I'm looking at the timestamp to see, is the timestamp greater than the last time we ran the ETL? One piece of this that depends on an outside structure is, if I am doing a load like this, I need to keep some structure, some table, some file that will track the last time we actually ran the ETL, because that's going to be my ending point for this load, which will be the starting point for the next load. So I need to be able to know exactly when we ran the ETL. So it's basically a bookmark to use for the next time. So the way that I do that is I created in this script, and I'm using the same example throughout all these demos, is creating a table called update timestamp. And it tracks just 2 columns. It tracks the table name and it tracks the date on which we ran the ETL. You can use whatever you want. Typically, this is actually what I use. I might have a couple of extra columns if we need to get more specific about the metadata, like load process ID that actually loaded that data. But for the most part, these are the 2 columns that I'll always have if I'm tracking the last time we ran the ETL for change detection purposes. So that's the first table that we'll use, and again, we'll use the same one throughout all of our demos that relate to some sort of a timestamp. So I've got let me make sure that I ran that. And I think my machine thinks it's a Monday. It's For some reason, every time I switch context on one of these queries, it slows down on me. Bear with me just a second here. So make sure we got our person table set up. We've got our update timestamp. We're going to do some updates. So what I did here was, after I've got that table set up, I've got a person table that we're going to interact with, and that's the same table that we'll use for all of the demos that we have here. So I'm going to perform an update on the person table, replace a login. I'm going to replace AdventureWorks with simply AW. You can see that on the row count output, we had 290 rows that were impacted. So we performed the update. We set up the update timestamp table that tells us the last time we ran the ETL. Now let's actually check for changes here. So what I'm doing is I'm grabbing from my person table where the modified date is greater than, then I'm doing a query select last load timestamp from that update timestamp table. This is the one that I showed you in the first query to indicate these are the records that have changed since the last time we ran the ETL. So that becomes the forward of, or the as of point that we're using for all of our subsequent queries. So this is where our ETL would pull. So this is our source query that we pull into the ETL. Might be an SSIS package, might be a SQL query, might be a PowerShell or a C# script. It could be anything at all. But the bottom line is, to retrieve that data, I need to know when we start, and that's the last time we ran the ETL. And then when do we end is some arbitrary get date value. So it's the point at which we start that ETL. And then the last thing that we'll do is update that timestamp table to say that this is where we left off the last time. That's where we start the ETL process next time. So I've always got a fixed and defined start point and end point, so I know when to start and when to stop the ETL. The stop point for this ETL process becomes the start point the next time we run that, and that's what we're facilitating here. So I'm going to run that, and it might be a little hard to see, but down the bottom right, we updated 290 rows in the previous step, and we're now seeing that we have 290 rows that were retrieved with that query, showing for the changes between the last update and the current time. Now, if I rerun this query, I should get 0 results here. So I'm getting nothing at all because I updated that timestamp. That's saying the next time we run the ETL, this is the date stamp we're going to use. And there weren't any updates between here and there. If I go back to my other query and run another update on that same data, then we would see some data as a result of this query. But since we didn't, we're seeing nothing, which is exactly what we expect to see. Now, this is using the update timestamp, and I mentioned that that's not my favorite way to handle it. This does work, so we can make this work, and if you don't have any other way to do change detection, if you're dealing with, I see this a lot with vendor databases, for example, if the vendor only gives you a date stamp to be able to use, this can work. But make sure that you know the risks, because if there's some process that inserts or updates data that doesn't subsequently touch that timestamp, you'll end up missing some data in your ETL, and you could have data that was changed on the source that isn't subsequently reflected downstream in your destination. Sorry about the hangs on Management Studio. Give it a second to catch its breath and catch up. So the second thing that we'll do is I'm going to use change tracking, and I probably should have led with this one because, as I mentioned earlier, all of the things being equal, if I'm designing a brand new system, change tracking is absolutely my go-to method for doing changes. So the way that works is, let me minimize the window to the left. So to give you an idea of how that works, I'm creating a table. So this is similar to what we used earlier. I'm devoting a separate table to just change tracking. Now, this is not the source or the destination table. This is similar to the table that we used previously for that timestamp value to show us when the last time that we ran the ETL was. The difference here is that change tracking doesn't use a date stamp. It uses a version number to track the last time something was updated. So you can see this differs just a little bit from what we had previously, where I've still got the table name. I've still got another column that we're tracking. This is no longer a date. This is now a big int value. That label or that version number that's used by change tracking is a big int, and it will increment every time we make a track change on any table in that database. So I'll set up that table, make sure it's empty if it does already exist. Now what I need to do is I'm going to take a two-step process to turn on change tracking. So the first thing that I'll do is I'm going to make sure that change tracking is enabled on the database. It is not enabled by default on every database, so I have to turn that on specifically. You can do that in code. You can also do it, I'm going to jump over to the UI for a second in the Object Explorer, go down to my change tracking database. I'm going to right click on it, go to Properties, and you can see in the left side on the menu, I have a menu option for change tracking, so I can do this in the UI as well. And it will show me right now I do have change tracking turned on. It is set to true, retains data for 14 days, and it will automatically clean up old versions after those 14 days expire. This is not the default setting. By default, it will be turned off. And even when I turn it on, the default retention period is 2 days. I always like to bump that up to something a little bit higher because that means that in 2 days' time, the records of those changes will start to fall off and you can no longer use change tracking as an accurate way to handle that. Doesn't mean that your entire load is invalidated, but it may mean that you need to go back and do a full load rather than an incremental load to let change tracking catch up. So that's on the UI side. I really want to stick with code because that's the more easy to automate way to do it. So set it up on the database. That still doesn't turn it on to track any tables whatsoever. That simply allows us under the umbrella of change tracking. Anywhere in that database, I can turn on any of the other tables and set those up for change tracking. So once I've got that set up, alter database change detection, set change tracking on. I want to override the default of 2 days and use change retention period of 14 days. Once that's set up, I can now go table by table for any tables that I want to use on change tracking, alter the table, enable change tracking, track columns updated, so you can track the specific columns that were updated. So that would give you the functionality to look at a row and say, not only did it change, but these are the columns that changed. Now, I'm mostly a data warehouse guy. I typically don't care if the first name or the last name changed or the age or the city or whatever. I don't really care about that. I care that the row itself changed, and I'm going to handle that the same no matter if one column changed or all of them changed. Typically, I don't need that, but I want to turn that on and just show you that option is available. You do have the option to pull back the specific columns that have changed and not just at the row level. So once that's set up, pardon me. So I'm going to delete from my change tracking table that we created previously, and now I'm going to insert into the change tracking table. This is not the change tracking table that we're using up here. This is the metadata table that we're using to track the last version number that we processed for the ETL. Again, this is going to be a big int value. The way we retrieve that is when we turn on change tracking, there's a function that's enabled called change tracking current version. That returns the big int value of whatever the current version of change tracking is. That will increment once per operation, not necessarily once per row. So if you do an insert, it's going to increment that one time. If you do an update and update 100,000 rows, that will also increment that just one time. So it doesn't do per row, it does per operation. In fact, just to show you the output of that, let me run that by itself. I can run select change tracking current version, and it'll give me, because I just set up change tracking, I'm not getting anything at all. However, when I start making some changes in the next step, we'll see that that will be a non-null positive number in just a second. So make sure that we got that set up. Change tracking is up and running. Go back over. We're going to make some OLTP changes. It looks like I've already got that script open. So I'm going to update some records. I'm going to insert some records. Finally, I'm going to delete some records. And again, before we did that, we inserted into our change tracking metadata table whatever that current version is. Right now it's null. So insert into that. I had 27 updates. I had 3 inserts. I had 35 deletes. So now if I go interrogate change tracking, so this will happen in a couple of steps. I already know, based on that last table that we had, or the table that we had inserted into for metadata tracking purposes, I already know the big int value for whatever the last version of the ETL operation was. Right now it's null, so I know that everything forward of that, basically everything forward of 0, the way I'm going to handle it, will be included in that. And what I need to do is, just like we did with the date period, I need a beginning date, date time, and an end date time value so I can get everything between there. Doing the same thing here on change tracking. The way that I'm doing that is I'm declaring a T-SQL variable called CT version end. I'm going to call that change tracking current version function again, and when I did this earlier, you remember that was null. Now if we run that, that's curious. Let me make sure that I ran this okay. Yep, I did run that. All right, this may not turn out to be an optimal solution. We're going to go ahead and execute that. All right, so don't look at this as a failure of change tracking. There's something that I'm doing wrong in my script. But effectively what this ought to return using that change tracking current version, because we did have some changes, it should be returning a non-null value. For some reason it's showing me still a null value just for fun after I did that operation. Let me run that one more time. All right, so now it's showing 26. That's curious. So circle back on that, but I do want you to be aware that when you use that change tracking current version function, it pulls from change tracking whatever that current version is. The way that I consume that is there's another function called change table. Change table is a change tracking specific function that lets me get all the changes from a specific table since a last version number. And the way that I'm doing that is selecting, so using it just like a table. I'm selecting from change table. I want to get, this will take 3 parameters. I want to get changes. I don't know why that's even a parameter, because it seems to me you would always get changes. Your other option there is to get, you can type in version, and it will give you one specific version, not everything that's changed, but show me for version 25. I think 26 was what we saw a minute ago. For version 25, show me all the changes related to that. So I've never used version, just use changes. Will give you all the changes for this table since the last time we ran the ETL, okay? And then I'm left joining that to my person table, and then I'm filtering the end version as well. So this is my start version, what we pulled from our tracking table, or the metadata table that we inserted into in the previous step. And then I want to filter that by the end version, which is what we got right here. So it'll give me everything between there. Once I run my ETL, and that's what the pseudocode indicates in here. So this is my select query, this is my source query. I'll run my ETL, and then finally I'll run my change tracking, or I'll run my script to update the change tracking variable so that next time the ending point for this load becomes the beginning point for the next load. And when I run that now, so I'd run that previously, because I just updated that, we updated that at the end of the last step, it doesn't show me anything. By design, it doesn't show me anything. Now if I go back to my metadata query and I do one more update, well, we're not selecting anything from there either. So if I did that update, go back over here, then it would pull all the changes that were impacted as part of that. We didn't do any updates. It updated 0 rows, so none were impacted. But this is by far the simplest and most lightweight way, if you have control over your source database, to do change control. If you enable this, again, it's set up at the database level. It's enabled on a table-by-table basis. Its impact is very minimal, and I've found that it is a reliable way for detecting changes. But the biggest assumption, as I mentioned, is that you have to be able to modify your, well, 2 things. That your source is a SQL Server source, obviously, but you have to be able to modify that to enable change tracking. And I've had, when I go to clients with that, go to their DBA staff, I've had some mixed results. Some of them are more than willing to do it. Some of them really want a lot of information, a lot of testing before they enable it. Certainly appreciate the cautious approach to that. But I've never, in all my uses of change tracking, I've never run into a case where we enabled it and then had to disable it because of performance reasons. It's always worked well with respect to performance and accuracy and ease of use as well. All right, I'm going to briefly walk through change detection. I'm not going to spend a lot of time on this, not going to spend as much time as I did on change tracking for a couple of reasons. First of all, just in the interest of time, but more specifically, I don't see change data capture used a lot for change detection purposes. It is suited for that purpose, but it's a little bit like using a sledgehammer to kill a fly. It really is a data audit tool. If all you need is change detection, change tracking or some other similar mechanism will probably work well. Change data capture certainly will get the job done, but it's a little more of a heavyweight approach, a more invasive approach, and can have some performance implications as well. So I'll walk you briefly through what change data capture looks like. So just like we did previously, we enable it or disable it on the database level. So using either CDC disable DB or enable DB to turn that on. And then on a table-by-table basis using SPCDC enable table, that's how we turn that on. Once that's turned on, in fact, if I run this, it's probably going to give me a warning about SQL Server agent not running. So when I run that, yep, there it is in the bottom. So it does require SQL Server agent. The way that change data capture works is that it reads from the transaction log on the database, and that's how it detects what changes were made. That operation is done by SQL Server agent job that's running, and I think it's scheduled to run every minute. Whenever you turn on a table or turn on change data capture for a specific table, it creates a job specifically for that. So turn on 10 tables, it'll have 10 jobs out there for you. And those are constantly running for the purposes of change detection. From there, you would use it similarly. I'm going to skip over the OLTP changes, and I'm going to show you how you would map that in. The way that you query this is a little more complicated than what you would do on change tracking, because you're still using some functions. In this case, you're using a user-defined function, or in the case, a system-defined function, to map a time to a log serial number. So smallest greater than and largest less than or equal to. These are basically how you filter out the timestamps on change data capture. But beyond that, it will tell you the full history. It doesn't just give you this row was changed, but if I use the function CDC get all changes for DBO person, and this is a function specific to that one table, it will give me all the changes between beginning and end. It will report all those changes. If that row was inserted, if it was updated 3 times and then deleted, it will show me all that information in change data capture. Again, there are cases where that's necessary. If you need to get a full data audit rather than just a change detection query, CDC is the way to go. And I don't want to talk you out of it if you do need a full audit mechanism, but if all you need is change detection and not auditing, this will get you there, but it does have a little bit of extra baggage as well. So typically for that, I've used change data capture, but I tend to avoid it just for if it's only a change detection scenario. All right, let's talk about temporal tables. If you're on a version older than 2016, this will not apply to you, but if you're on 2016 or any newer version that will follow that, temporal tables can be a good way to manage your history. So again, this assumes that you can modify the source database, so this runs on your source database. But effectively, it will track your the source data, and it will give it a version number, or rather keep the version history for any table that you enable for tracking. So in this case, the way that we turn that on is, scroll down just a bit, I'm recreating my table here. So here's my table person, same table that we were using previously. And then I am turning on temporal tables for this. So period for system time, valid from and valid to defines when the period, the timestamp, when the record was valid from, and then to, and the way that I'm implementing the temporal table is turn on with system versioning equals on. That tells it turn on the temporal table or make this a temporal table. I have to identify the name of the history table that we use, so this will be person history. If I go into Management Studio, I will actually see what looks like 2 different tables, and one will appear like it's a child of another. I can query those independently, but really it's intended to be consumed as one entity, one with the original table person having the current record, whatever that current record is, and then person history will store all the history, all the changes that have taken place. And then we'll insert some records into there, perform an update, and then we're doing the same thing that we saw previously. So I mentioned that table at the outset. We're storing a metadata table. I'm calling it update timestamp, and that will say this was the last time the ETL was run. Create, insert into that table whatever the current data is. We'll run that. And again, this is the same table that we were using previously, but if now I go to Management Studio, right now we can't see that it's been enabled. Right now I've still just got, I don't have it listed as a tracked table. So if I open the right database, it'll show up fine. So once I turn on temporal table, or once I make this a temporal table, you can see that even the moniker, even the icon in Management Studio changes. It puts a little, looks like a stopwatch, and it indicates that it is a system version table. Now, I mentioned earlier that we are creating, as part of this process, we're creating another table called person history in this case, and that will show the history. We don't see that in here, but if I drill into that table, I'm not sure why RedGate's throwing an error on that. If I drill into that, you can see that below there, it's almost like the table has a child. So here's the person table, here's the person history child table. Again, independently, those will look just like regular tables. I can query person, I can query person history. But the way it's intended to be used is that there's a couple of temporal table functions. Let me go run my OLTP changes. We'll let the screen hang on itself for a second. So when I run these OLTP changes, what it will do is for every record that gets updated, it's going to insert a new record into that history table. So all my history is preserved in that person history table. So if I need to look at just the current record, what is that person, so the insured that I mentioned a little bit earlier, where does the insured live right now? I can query just that base table, and it will show me that information. If I want to see where did this person live at a given time, or show me all the places where this person has lived, or show me if this person has changed names. If that's a system version record like that, I can query that history table or use the functions directly and get all the information about how that record has changed over time. For those of you who work with data warehousing, this will work a lot like a slowly changing dimension, except that the system is managing the entirety of it. It's describing what the record is, when it was valid from, when it was valid to, and then in a separate store altogether, it's actually showing where that table or what the current record is for every person. So back on my update, I just ran an update, update my person table here, 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 and so on. I did some inserts as well. And the way that I consume that as a temporal table, there's a couple of different ways that you can do it. I'm keeping it fairly simple in that I only want a list of the person records that have changed. So I'm grabbing the ETL date, again, from that ETL update timestamp table that we created previously. And that's going to be my starting point. I'm using an inner query to query against my person table. This is where the valid from, so that's the field that we're using for the system time. Any temporal table that we, or any table that we set up as a temporal table will have to have a valid from and a valid to timestamp, and that's what we're consuming here, is simply show me everything forward of whatever the last ETL date was. So if I query all that, this will give me, I've got 284 records here. This was what we changed in the previous query. So if I look at all these results, that should add up to the number of records that were touched, should be 284 altogether. And from there, we process it in exactly the same way that we did change tracking, the same way that we did the update timestamp. Once we're done with the ETL operation, our source query is here, our ETL operation would take place here, whether it's an SSIS package or some other mechanism, and then we update that timestamp. So if I run this, I'll see those results. Now that we've updated that timestamp with the current date, if I run that again, I see no results because we haven't processed anything further since that last update. I can jump back over to my update query, run that again, and then I would see some results in that history table. But for right now, because we're limiting that to the last load timestamp, we're not seeing any of that. Admittedly, I've not used temporal tables a lot because they still are fairly new, and a lot of my clients are still on either 2012 or 14. But if 2016 is in play, this is an effective way to manage change tracking. Again, it does assume that you can modify the source. This assumes that you're running all of this on your source database, but if you have that assumption that you can modify the source, turn on temporal tables, this can be a good option for managing your historical load. All right, quickly I'm going to walk through what a hash looks like. So effectively, we were talking about this earlier, the hash is that I take several columns, I convert those over to a varchar or an nvarchar. I use the hash bytes function in T-SQL, and I make a big binary hash from all of those. That's what I then use to compare source to destination rather than first name to first name, last name to last name, and so on. And the way that works is the hash bytes function takes on a parameter of the algorithm that I want to use. I typically always use SHA-1. You might have read recently that SHA-1 was cracked theoretically by, I think it was Google or Google researcher that had cracked that. That doesn't necessarily invalidate it for change detection purposes. If you're using it for hardcore encryption, possibly. But SHA-1 just for change detection purposes is still a very valid entity, a very valid algorithm to use. So I'm using SHA-1 and then I'm coalescing all my values, casting each one of them into a varchar. You don't want to do this without the coalesce or the cast, because if you try to add an integer to a string, it might not work out well. If you try to add, or if you try to coalesce a non-null to a null, we know that that turns into a null. And if you run a hash bytes on a null, you're also going to get a null. So make sure that you're making equivalent all your data types, and then for any concatenation that you use, you're coalescing that so that you don't get a null value bubbling up there. I also recommend using a spacer in between there. So if you're concatenating my record, it would be Tim pipe, Mitchell vertical pipe, Mitchell vertical pipe, whatever other details, because if you're concatenating those values together and for some reason you had two values, like if you had a person with having a hard time coming up with an example, but if you concatenate two values together and you're not using a separator, if you're concatenating AA plus BB, but you have someone else that's A for the first and then ABB for the second, concatenating those together and then hash byting those two will get you the exact same value when in fact you're concatenating two different values. Use the separator. I prefer the pipe because you rarely see the pipe in real data, but I have gone so far as to do something like this where there's no reason under the sun. I really shouldn't see a pipe in the literal data, but there really shouldn't ever be this combination of characters. So as long as you're using a combination, a character or a combination of characters that would never be seen in the data, you'll be safe. But create that hash bytes. What I'll typically do is if I have control over the destination, I'll go ahead and put that hash bytes value into the destination. In this case, I'm writing into a new table called ods.person, and we're writing that hash bytes value into a new column into that table so that I don't have to recalculate this every time. There is some measure of overhead to recalculate that hash bytes because you're basically creating an encryption value based on all of these. So if you can avoid doing that every time, only calculate it as it goes into your destination table, but persist it in that destination table, it'll cost you a little bit less. But even if you have to calculate it on both sides, even if you can't modify your destination database, this might still be a better way to go than the column by column comparison. And the way that would work in consumption would look something like this. So we'll let that catch up. So I'm using a CTE to bring together, select everything from my source, including the hash byte. So I'm calculating this from the source data, not from the destination data. This should be the only time that I'll need to calculate this. So calculate it from the source data as soon as our query window catches up. So you can see that my comparison here, or my selection of my changed data, is much simpler. I don't have to compare first to first, last to last, and so on. I'm looking up based on the business key, and then where person ID equals person ID is the business key where those match up. And then where row hash is null, either of the row hashes is null, or the row hash on the source doesn't match the row hash on the destination. This part is going to be extremely fast. In fact, we could probably make that one statement, coalesce row hash from source, row hash from destination, and make that query even simpler. This will cost you a lot less than first name to first name, last name to last name, and it also makes for simpler code as well. So if you're comparing on the destination side, this is an effective way to go. I've got another example that would show brute force, where we're comparing everything from the first name, or rather the first name to first name, last name to last name, and so on. I won't go through that because you probably used that method before. That one has the least amount of assumptions, like I mentioned earlier, so it can work, but be aware that it does have the highest performance impact as well. So last thing I'll show you is I'm going to change context and jump over to SSIS. So regardless of what you're doing anywhere else, on the SSIS side, if you need to make changes, let me run back and run this setup and the query. So on integration services, if you want to do everything that we've been doing up to this point, whether it's with brute force or with a hash bytes, you can do the same thing in SSIS that you can do in the database engine. I mentioned a little bit earlier that the lookup transformation is an effective way to do those lookups, and that's exactly what I'm doing here, where bringing in my source data, this is from my person table, same one that we've been working with previously. Bear with me just a second while I run the setup query. And then back over on SQL Server, or rather SSIS, I'm going to look up the business key. If there's no match on the business key, I know it's a brand new record, so I can simply insert that into a new OLEDB destination if it doesn't match on business key, and in this case, it's just person ID to person ID. If we don't have a match, then I'm using another lookup transformation, and I'm going column by column. So this is the brute force method. Again, it's a little bit ugly, but it has the fewest assumptions. SSIS will let me do this. It will let me do, if I'm calculating the hash, I can also use that hash bytes function in SSIS to do the same type of thing and compare only the hashes. But this is probably the most easy to understand because I'm comparing simply first to first, last to last, and so on. So first query. So I'm not sure why that one's hung. Will not stop and troubleshoot that one. But the bottom line is, when I run this, if it will run with that other query running, yeah, it won't. With that other query running, it's going to lock up because it needs to validate the metadata. Bottom line is, everything that we do on the database engine side, you can also do something similar in integration services, either through column by column comparison or through using a hash bytes comparison. All right, couple of final thoughts. If you can filter on the source side, change tracking, change data capture, temporal tables, it's preferable because you're touching less data. But if you need to, you can also bring in the entire set, compare it to the destination, using hash, using brute force, using SSIS. And then integration services can be used either directly to use the pieces that we were showing on the data flow, or it can consume change tracking, change data capture, and so on. So I think we've got just a couple of minutes left for questions. So Kenny, if you guys have got any questions that we can answer in a couple of minutes, we do have a little bit of time remaining.
I've got one that I've had my eye on this whole time. It says, in production, I've had some issues with change tracking, more than 14 million changes a day causing bloat in the change tracking tables. In 14 days, how many changes do you generally see?
So if that's a great question. So how many changes do you expect to see? The answer, as always, is it depends. If you're getting a huge velocity of changes, that means that either one of two things is happening. Either you've got a lot of things that are being inserted into your database, or you've got a lot of individual piecemeal changes that are taking place. If a significant portion of your data is changing in between your ETL processes, or rather in between your whatever that timeout cycle or the expiration cycle is, you could see some measure of bloat. Typically in a data warehouse scenario, I'm seeing a small single-digit % change every day, if even that. So for data warehouse loads, it typically works really well. If you've got an OLTP system that's got a very fast velocity of changes, you might have to consider some other tool, even though I've never run into a scenario where I've had to abandon change tracking for performance purposes. But you also might experiment with bumping down that retention period. Typically it's 2 days by default. maybe bump that down to 1 day. I think you can cut that down to hours as well. You have to be careful with doing it with hours, because if you miss one load, for example, you could fall outside the realm of what will be retained by change tracking. But ultimately, reducing that retention period can help with some of that bloat. But in my experience, again, with mostly data warehouses, I've never had to bump that below anything below the default value of 2 days.
We're right at 2 o'clock. Tim, if you don't mind, I think I'll just bundle up the rest of these questions and send them to you.
Okay.
If you could.
Yep, absolutely. And I've got my contact information here if you've got any specific questions about anything that we talked about. If you want to keep in touch, hit me up on Twitter, hit me up on my newsletter. I'll be glad to reach out if there's a question that I can answer for you. Just let me know.
All right. Thank you very much, Tim. Guys, we'll see you next month.
All right, thanks,
have
everyone.
a good day.